Okay, from last week, I just have a couple examples that I would like to go over. If you had chose to wrote them down, I can't remember. I said write them down, don't write them down. But even if you didn't, I think we can pick up on this content fairly quickly. Okay, so if we had a compound like this, okay, so with that, if you had this type of compound, we would say start with carbon or nitrogen. See if they are present. That's what you'd want to put in the center. Okay. Then if neither one of those are present, then you want to put metals in the middle on account of because they want to give their electrons away. And then, well, what about if you have some of these examples like sulfuric acid we had done was H2SO4. Again, we don't have carbon, we don't have nitrogen, okay? And then we don't have a metal. We have this that has metallic-like characteristics, but we can't put that in the middle. So when you're looking at components like this, well, then you'd want to choose probably the non-metal that's in least in number, like we did H3PO4, phosphorus would go in the middle. H2SO4, we would put the sulfur in the middle. Then the oxygens would be surrounding that sulfur, or the oxygens would be surrounding that phosphorus then. But in this case, if we see this as HO or ONO, or however you want to say that, we see nitrogen, we're going to put that in the center. And let's maybe approach this how maybe you would normally try it. We know that nitrogen is in column 5, so you might try 1, 2, 3, 4, 5, and then try putting an oxygen there. We know that's in column 6, because remember, we know that whatever column these elements fall into, that tells us our valence number. And you might try putting an oxygen over here. Okay. And then we got that one hydrogen left over, thinking that maybe this would work. Well, this nitrogen's got 8, but then each one of those oxygens only has 7. So then we know that this will not work for this compound. The idea of putting nitrogen in the middle, that is the right idea. So that does not work. So remember, nitrogen and oxygen can do something significant that many other elements can't, and that is forming a double bond. So in this case, let's go ahead and try one. Okay, so if we put 2 unshared pairs of electrons up here, there's 2, 3, 4, and then we'll put one over here is 5, okay, because nitrogen's in column 5. So we said we're going to try a double bond, so let's go ahead and do that. Okay. Then that takes care of our nitrogen and oxygen. Let's go ahead and try to put an oxygen over here. Then there's our 6 X's, and then there's our lone hydrogen, and therefore we see that that works. Okay. Okay, we're back. I had to cough really bad, and I didn't want that to go in the microphone. So we see that with this nitrogen, it's got 2, 4, 6, and 8. There's a double bond right here. This oxygen's got 2, 4, 6, and 8 because that double bond is sharing them. Then this oxygen has made a bond with this nitrogen, 2, 4, 6, and 8. Okay, so that is one way that we could write that. Tomorrow, I'll show you a different way that you could write this compound, but this is an example of covalent bonding as opposed to that of ionic bonding. So let's look at an example of an ionic bond, and maybe that would be, we'll even do a polyatomic ion. Let's maybe do calcium hydroxide. Okay. So in this case, we know that hydroxides are -1, calcium's +2. Therefore, 2 times 1 gives us 2. -1 times 2 gives us -2, so we know that this compound is correct. We don't have carbon, we don't have nitrogen, and we don't have a compound, again, like those acids, but we do have a metal. So we're going to go ahead and put this calcium in the middle. Because remember, metals want to give their electrons away. So here's 1 and 2. So there's where that positive 2 came from. Those electrons were given away. So we've got 2 oxygens and 2 hydrogens. So we'd put an oxygen here. Again, in column 6. And then here we go in column 6 again. And there's just 1 left over. We've got 2 hydrogens to work with. So we put them there and there. Okay? Calcium doesn't have any electrons around it because it doesn't want any. And again, one of the aspects you might have done when you're in physical science, it's not necessary, but maybe for some of you it's easier to see that than to illustrate that all these have 8 electrons around it. Maybe, but don't do that if it confuses you. Okay? So we could do the same thing with this. This is what I mean. That calcium doesn't have any electrons around it, but it doesn't want any. Same thing with that of the hydrogen. That does not have any electrons around it because that's how the hydroxide ion would look. It gave its electron to that of the oxygen. Okay? Covalent bonds, a metal and nonmetal, those are ionic bonds. Okay? And then one last example I want to go over is what happens when you have carbon and nitrogen together. Well, let's go ahead and take a look. I think we can erase this. Okay. In this case, what if we had some sodium cyanide? Okay. Typically what happens is that cyanide ions, that's something you possibly have heard of. Yes, that is a poisonous gas, and we're bonding that with some sodium. And maybe go ahead and take a couple of moments to try that for yourself. I'll just hit the pause button here, and then go ahead and start and see once what you can come up with. And some of you may have been stumped, and that's okay. That's why we're working on this together. Okay, so what color marker should we, well, just use this one. Okay, so here we see carbon is in the center. You could put nitrogen there, but I think it would be easier to understand if you put the carbon in the center. So a logical approach you might take, carbon's in column 4, so that's what you might try. And then remember, unshared pairs of electrons, keep them together. Okay, and 1, 2, 3, 4, 5, and then we got a sodium. Try putting that over here, and then notice we're nowhere near where we should be, even if we keep our unshared pairs of electrons together. If we put them up here, and then there's nothing for that to bond to, but you could say, well, move the sodium over there. Well, the moment you do that, well, then you lose this electron over here. So then hopefully what would, let's say, jar your memory is saying, okay, so the single bonding isn't working. Well, maybe let's try a double bond between the two. Okay. Well, as we try that, let's go ahead and take a peek. Okay. So carbon and nitrogen can do double bonding as well. And then we've got, you could say 2 electrons over here, but notice we're not going to have anything to bond it to, even if you put a sodium over here. Okay. This nitrogen only has 7, 2, 4, 6, and 7. And then this carbon's got 2, 4, 6, and 7. So that single bond's not working, double bond's not working. But remember, carbon and nitrogen can do something that only those 2 elements can do, and that is triple bond. So if we look at in this fashion, carbon, and then nitrogen. Okay. So I want you to take a look at that and just see once what we have left. We've got our carbon accounted for, our nitrogen accounted for, but we still have this sodium. I want to see if you can see once what we have left to do. So ponder on that for just a few moments. Remember, carbon's in column 4 and nitrogen's in column 5. Okay, you can try splitting these last two up. Okay, and then this one's got one more. So there's 3 and 4 for that carbon. There's 3, 4, 5 for that nitrogen. What we see happening, there's our lone sodium, which technically you could say we got that, but these are unshared pairs of electrons. So the thing to do would be to keep them together. So put that up top here, and that's how you could write sodium cyanide. All right. So that's all we wanted to go over for today. We'll have a paper for you to work on tomorrow. So we will catch up to you next time.